If you are representing hexadecimal, you are not supposed to write only 1 0 since it is 0. So you have to use 4 zeros. So what is this ASCII values? American Standard Code for Information Interchange. Hello everybody, I welcome all of you to the last session, that is third session on data representation. So what is that we have done in the session 2 and session 1? So before we start this session, I want all of you, if you have not subscribed to the channel, please click on the subscribe button, and if you get some information out of this session, please don't forget to click on the like button. Alright, so without wasting much of your time, let me take you to the session. What is that I'm going to discuss in this session? So before that, I would like to give you a small recap what is that we are doing. Alright, so in all the previous sessions. So let's start and let's have a quick recap on what we have done in the previous session. So please make a note of it. So we were discussing different number systems what we have. So please understand, so what is the different number systems that we had? So we had binary number system, we had decimal number system, we had octal, and also we had hexadecimal. We have understood we have 16 different number conversions we have. I have discussed some of the different number conversions in my previous session. So the continuation of previous session is what I'm going to discuss now. So what is that we are going to discuss in this session then? So I will be discussing how do I convert hexadecimal to binary. Please understand, how do I convert? I will be explaining, I will be discussing, and I will be showing you how do we convert hexadecimal to binary. So that is the first conversion which I'm going to discuss with all of you. The second one that I have is octal. So how do I convert octal to hexadecimal? So please understand, how do I convert octal to hexadecimal is what I'm going to discuss, or I will be showing you with an example in this session. Along with that, I will also show you hexadecimal to octal conversion also. So this is the three different conversions which I have to do it. So I will be explaining that in this session with all of you. Alright, apart from that, I will also show you what is binary arithmetic, how do we perform addition, and how do we perform subtraction. So that's what I will show you in this session. Along with that, I will also show you what exactly you all will be knowing, ASCII values. All right. So along with that, we have something called, I will be showing you. So in the last slide, so please keep waiting for that. So watch the video completely. All right, that's going to be something new for all of you probably. So without wasting much of your time, let's start the conversion. So what is the first one that we have? As I told you, we will be starting with a hexadecimal to binary. So we all know that hexadecimal, in the sense the number which starts from 0 to 9. Okay, all right. After that, I don't have 10, so I have A instead of 10. So how many numbers we have? In total, we have 16. So 0 to 15. But the problem that you need to understand is I don't have 10. So instead of 10, I will be using A, B, C, D, E, and F. So this is what the code which I will be using to represent 10, 11, 12, 13, and 14, and 15. So please make a note of it. So that is the first knowledge that I should have before I start this problem. So you all know that. So A is equal to 10, right? That's what I'll write it this side. A is equal to 10, B is equal to 11, C is equal to 12, and D is equal to 13, 14, and 15. So this is what you should know. All right. So I know this basic knowledge. So let's get into the problem. What is that I have? What is my problem that they have given here? So they have given 10 AF. They have given 10 AF. Purposefully, I have taken this problem because you will make a mistake here. As I told you, there is no number. We don't take any number called 10. We don't take any number called 10. So if I write, so 1, 0, you should not read it as 10 because I don't have the number called 10. I don't represent the 10 in the hexadecimal. Point number 1. If I write 1, 0, you should not treat it as 10. Instead, you should treat it as 1 and 0. This is two different numbers. So that is what you need to make a note of it. So if I have the question 10AF, so you should consider it as 10AF, four different numbers. This is not 10. That is the first point that I wanted to make it very, very clear at this point of time. So fine, we understood. Then how do I convert this hexadecimal? How do I convert this hexadecimal to binary? So that's the thought that I have now. So how do I do it? How do I do it? So yes, guys, we have the simple method. The method which you should remember here is, see, for example, I will be writing whatever the numbers that they have given. So I will write it separately. What is that they have given? 10AF. I have written 10AF separately. So you all know that if I am using hexadecimal, so what is the code that you should remember? You should remember 8421. You should remember 8421. So fine, I have 8421. All right, using that 8421, I should try representing this 1. How do I represent 1 using this 8421? So I want 1. So let me just make it. So do I want 1? Yes, I want 1. So 1 into 1 is 1. Okay. So do I need 2? No, I don't want. I will make it 0. So 0 into anything is 0. 1 plus 0 is 0. All right. Do I need 4? No, I don't want. So 0 into anything is 0 again. So I don't need 8 also. So guys, 0 plus 0 plus 0 plus 1. So I got 1. So what is the code here? So 0001. So I write 0001. Please understand. Now I have 0. So I want 0. It is mandatory that if you are representing hexadecimal, you are not supposed to write only 10 since it is 0. So you have to use 4 zeros because you are using the code 8421 to represent that. That is very, very important. All right. So that's why I have taken 4 zeros. All right. So there is no doubt in that. So I have A. What is the equivalent value of A? So I have A is equal to 10. Then how do I represent 10 using 8421 code? So you have 8421. So how do I represent 10? So please understand. Do I need 1? I don't need 1. So I'll show you how. So 0 into 1 is 0. So fine. Do I need 2? Yes, I need 2 because 8 plus 2 is 10. All right. I will make it as 1. 1 into 2 is 2. So do I need 4? No. So 0 into 4 is 0. So do I need 8? Yes, I need. So I will write 1 into 8 is 8. So 8 plus 0 plus 2 plus 0. So it will give me 10. So for this, what is the binary bits? So it is 1010. Do I have 1010? Yes, I have 1010. In the same way for F. So what is the equivalent value of F? 15. How do I represent 15 using 8421? I need to add all these things. So I should have all this number. So I will get 8 plus 4 plus 2 plus 1 will give me 15. All right. So for that, I will write 1, 1, 1, 1. So once I got all these things, I will write together base 2. So this is how I will be converting hexadecimal number to binary number. So this is what you need to understand with respect to the conversion of hexadecimal number to binary numbers. All right, moving on to the next method that I have octal to hexadecimal. They've given me the octal number. So octal number, the range you all know as I have discussed in the previous session, 0 to 7. So how many numbers I will have? Total 8 numbers including 0. All right. So total 8 numbers including 0. So that is the range. What is the base? 8 is the base. All right. How do I convert the octal number to hexadecimal? So it's quite tricky. So but still it is very simple. So please understand. They have given 1076. What is the number that they have given? 1076. Before I start my conversion, I have to check. So is it correct octal number? That is what I need to check. So yes, let's check. So 6, will it come in the range 0 to 7? Yes, it is coming. So 7, will it come in the range? Yes, it is coming. So 0, obviously, 1, obviously, yes. Perfectly fine. So this is an octal number. So do I have base 8? Yes, I do have. How do I convert this into hexadecimal is a challenge. You all know that we can convert this octal number to binary. Yes or no? Yes. How do we convert? We use the code 421, right? we use the code 421. So fine, do it now. How do we convert? Let's start from this side for a change. So 421. What is the number that I have? 6. To get 6, I will make this as 1, 1 and this is 0. How it is, sir? So please listen to me. 0 into 1. So it is 0. So fine. Add. 1 into 2. So it is 2. 1 into 4. It is 4. So 4 plus 2. It is 6. Do I get 6? Yes. Then what is the binary equivalent? So 110. So I'm writing 110. You got it? Alright. So fine. You got that. And then for 7, same thing. Use 421 code. So how do I represent 7? Using 421 code. I should make all the things as 1. Alright. I did. Okay. How? 1 into 1 is 1. 1 into 2 is 2. Plus 1 into 4 is 4. So 4 plus 2 plus 1 is 7. So binary equivalent is 111. That's why I'm writing 111. In the same way, I have 0. So please understand, I'm using 421 code. That's why I'm using 3 zeros. Suppose if I was using 8421, you should write 4 zeros. So here I'm writing 421 code. That's why only 3 digits. That's what you need to understand here. And then I have 1. Okay, how do I represent 1? Using 421. So I have 421. My dear students, I need to represent 421 with the 00001. So how it is? So please understand, I just want only 1. 1 into 1 is 1. So 0 into 2. 0 into 2 is 0. 0 into 4 is 0. So please add this. 0 plus 0 is 0. 0 plus 1 is 1. So I got this. So the binary equivalent is 001. So I have written that. So you understood how I got this row. You all understood how I got this row. So fine. Let me erase everything. So you understood how I got this. Okay. Now I have in the binary form. But do I need it? Do I need that in the binary form? No, I need that in the hexadecimal form. All right. You all know that. How do you convert binary to hexadecimal? Use that method now. All right. So how do you convert? So you will divide the numbers into, you will group the numbers into 4, 4. So 8421 code. So please observe from this side. So what is the number you have? Let me just write it for you. So you have 0, 1, 1. Okay. You have 111. Okay. You have 000. What is the next one? You have 001. Okay. This is the number that you have. So I need to convert this binary number to hexadecimal. How do I do that? So I will group 4 numbers now. So this is what I will be doing. All right. So 0, 1, 2, 3. All right. So this is what I have. 1, 2, 3, 4. All right. Fine. I have 1, 2, 3, 4. 4 I have. 1, 2, 3, 4. 4 I have. This I will convert it into hexadecimal now. So using 8421 code. All right. So what is the number that I have here? If I make it like this. So I have 842. Okay. 8 plus 4 is 12. 12 plus 2 is 14. So what is the equivalent of 14? So I will write it here now. All right. A, B, C, D, E, F. A is equal to 10. B is equal to 11. C is equal to 12. D is equal to 13. 14 and 15. So what is the equivalent of 14? That is E. So write E. So do I have here? Yes, I have. So what is the next number that I have? So please understand, I have this. How do I represent this? So 0011. So this number goes off only this 2. So 2 plus 1 is 3. So I will write 3 here. All right. Do I have 3? Yes, I have. So what is the next one I have? So guys, please observe. So 8421 code. Okay. All right. So I have I'll write it here. I'll have 0010. So 0 into 0 is 0. 0 into 0 is 0. 1 into 0 is 0. So 2 into 1 is 1. So that is it 2 into 1 is 1? No. 2 ones are 2. So I'll write 2. So what is that? You have 23e. Okay. I'll write the answer here. 23e to the base 16. This is the conversion. Do I have that? Yeah. Yes, I have. All right. I have the 23e to the base 16. This is how I will be converting the octal number to hexadecimal. So this is what you have to understand here, my dear students. All right. Let me go to the next conversion. So I have hexadecimal to octal. So what is that I have? Hexadecimal to octal. The quite, reverse method of what we have done in the previous problem. All right. What is that they have given? Let's have a quick look. So they have given the hexadecimal number, but I want to convert it into octal. How do I do that? So same method. So first you will convert this hexadecimal to binary. So how do you do that? So you will use 8421 code. You will use 8421 code. What is the code that we have? 1F0C. So how do you represent C, O, F and 1? So that's what we have tried here. So C we are representing here, okay? So and O we are representing, it's not O, it's 0. So we are representing using 8421 code is what you need to understand here. What is that? We are using 8421 code, okay? Here also F and 1. Let's understand how are we trying to do this. Alright, I'll erase everything now. So the problem that I have is 1F0C. So this is what I need to convert. This is an exact hexadecimal number. This is what I need to convert into octal. Alright, so fine, let's understand this, how to do it. So let me write it C0F1. So hexadecimal in the sense, please remember I have to use 8421 code. So how do I represent C, O, 0 and F? Okay. So C in the sense, what is that? So please recollect. A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13, E is equal to 14, F is equal to 50. So this is what we have. Alright, what is the C value that we have? C in the sense 12. How do I represent 12? Using 8421. Alright, so I should write 1100. Yes or no? Yes. Why? Because 1 into 8 is 8. Alright, 1 into 8 is 8. So fine, 1 into 4 is 4. 0 into anything is 0 plus 0 into anything is 0. So I got 12. So for this 12, the binary equivalent is 1100. So fine, I'll write 1100. Do I have that number here? Yes, I have. So check it. What is the next one that I have? 0. So I'm using 8421 code, right? So I'm using 8421 code. How do I represent this 0? I have to use 4 zeros. I have to use 4 zeros. So fine. What is the equivalent of F? F in this is 15. So if I use 8421 code, so how do I write? How do I represent it? 14. Do I have 14 or 15? It's 15. How do I represent it? So I should make it everything as 1. Because 1 into 8. So guys, I got 8. 1 into 4, I got 4. 1 into 2, I got 2. 1 into 1, I got 1. So if you add this, you will get 15. Right? If you add this, you will get 15. So I need to write 4 ones. Binary equivalent of this 15 is 4 ones. So I'll write 1, 1, 1, 1. So fine. I have 1. How do I represent 1 using 8421? So you have to use 4 digits, right? So I just want only 1. So rest everything I'll keep it 0. Why, sir? Let's try this. 1 into 1 is 1 plus 0 into anything is 0. 0 into anything is 0 plus 0 into anything is 0. So triple zeros, if you add, you will get 0. You have only 1. So that's why the binary equivalent of this 1 is 0001. So I will write 0001. So finally, you got 0001 and you have 4 ones and you have 4 zeros and you have 1100. Fine. Nokia model, old model. Alright. So you got this. Fine. Now, I have my result in the binary form. How do I convert this to, what is the next one? Octal. How do I convert this one into octal? So that's a challenge. So guys, octal in the sense you have to use 421, right? You have to use 421. So group it into 3 bits. I will group it here. Okay. So I will group it here. I have 1 here. Right. So again, I have 3 digits. I'll group it here. I'll group it here. And I have 3 bits. I'll group it here. And I'll group it here. So this is what I have done. Right. So I'll just erase it for you. So let me rewrite. So what is the answer you have? So 0001 and then you have 4 ones. Alright. And then you have 4 zeros. And then you have 1100. Okay, this is the number that you have. So what is that you have to do? You have to group it, right? So fine. You have 1 here, right? So I'm grouping it here. I'm grouping it here. I'm grouping it here. So I'm grouping it here. So I'm grouping it into 3 bits. So if I use 421 code, all right. So what is the value of this? So I have, what is the value for this? I have 4. So if you use 421 again here, so what is the value? 1. So if you use 421 again, you have 4. So if you use 421 guys, 7 and you have 1. All right. So this is what the number that I will get. So please observe the answer. 17414 to the base 8. So this is how you will be converting. This is how you will be converting hexadecimal to octal. So hope you understood this conversions, guys. So moving on to the next one. So before I move on to the next topic for all of you, I think I've discussed almost all the conversions that we have. I have not discussed how to convert decimal to decimal, octal to octal, and I have not discussed binary to binary and hexadecimal to hexadecimal, because it gives you the same result and same value. There is no change in the value, so you will not have problems on that also. That's why I have not discussed that. All right. So we have binary arithmetic. We can perform all the operations, all the arithmetic operations with the binary numbers. So here in this session, I will explain how do we perform binary addition and binary subtraction. It's very simple. Let's take two values. All right. How do I perform the binary addition for this? Let me just write A, B and sum and carry. All right. So if I perform 0 plus 0, sum will be 0. 0 plus 1, 1. 1 plus 0, it is 1. 1 plus 1, okay guys, if I have 1 plus 1, the answer will be 1, 0. So what I'll write, the sum will be 0 and the carry will be 1. The rest, everything is 0. I'll repeat, please understand, 0 plus 0, it is 0. Clear? 0 plus 1, it is 1. This is sum I'm writing. All right, this is sum. In the same way, you have 1 plus 0, it is 1. Okay. Suppose if you have 1 plus 1, so it is 1, 0. So this is sum and this 1 will be going for the carry. This is what you need to understand here. This is how we perform the addition. This is how we perform the addition. Check out the table for all of you. This is what I've explained in the previous one. So please observe 0 plus 0. Okay. So add in 1 and 2. So sum is 0 because 0 plus 0 is 0, and the same thing, carry is 0. I have 0 plus 1. Obviously it's 1. The sum is 1 and the carry is 0. And I have 1 plus 0. Obviously 1 plus 0 also is the same result. Sum is 1 and the carry remains 0. And then I have 1 plus 1. In binary, 1 plus 1 in the sense 1, 0. So this 1 will go for a carry. All right, that's what we have written here. Sum is 0, so which we written it here, and 1 is going for the carry, which I've written it as 1. That's how we perform the addition. That's how we perform the addition. So we have subtraction also. So please understand. So it's very simple. 0 minus 0 is obviously 0. And the next one that we have, it's very important. Please understand, this is going to be very crazy. All right, this is where you need to spend a little time. All right. So how do I perform when I have 0 minus 1? How do I perform the subtraction with respect to this? So can I perform? No, I will not be able to do it. So what is that I have to do is, I have to borrow 1, right? So if I borrow 1, so I will have 2 1s. All right, I will have 2 1s. So what happens is, I will subtract this 1 with this 1. So the difference is 1. So I have borrowed 1. So that's why I will have 1 borrow here and the difference is 1. So this is how I will be performing the subtraction, binary subtraction. So we have ASCII values. So what is this ASCII values? American Standard Code for Information Interchange. So we will be able to represent 128 characters using 7-bit code. So using ASCII values, we will be able to represent 128. Please make a note of it. 128 using 7 bit. That's very important. But what happens when it comes to when we want to represent the local languages? Like, when it comes to India, we have a lot of different languages, right? So for that, so we have something called ISCII. So we use this code to represent our local languages. Okay, we use this code to represent the local languages. All right, so this is what you need to understand with respect to the data representation. So by this, now I've come to an end of the session. So hope the session was useful and you learned some conversions today. By saying this, thank you very much. Please take care of your health. Bye bye.